Hi, I'm interested in contributing to the MITE database. In this video, I will walk you through the submission process step by step. Let's take a look at an example paper that I've recently read, and it's this one here. It's about cytochrome P450 in terms of, so it's modifying a biorelidite precursor. And in this publication, the authors investigated the substrate specificity of this enzyme SHYB. So this is an interesting article, and so I wanted to add it to the MITE database. First of all, the most important thing is that we find the enzyme identifier, the accession number, either a UniProt or a GenBank ID. And in many publications, this information is not findable, and it's really bad because then we cannot create MITE entries, since every MITE entry has to be about one specific enzyme that can be identified by either a GenBank or a UniProt identifier. But in this case, we can find this information in the supplementary information. So we have to scroll down a little bit. It's here at bioinformatics expansion of P450 biorelidite synthesis. And in this case, the authors describe a gene peptide ID. And so we can take this here. We can use this to search in the NCBI database, GenBank protein. Indeed, we find this enzyme here, and that's great because this means we can start with the preparation of the MITE entry. You can also look this up in UniProt, and in this case, it was found in UniPark. That's also good. MITE is also permissive towards UniPark IDs. So we have this most important information gathered. So let's take a look at the submission portal. And I've allowed myself to already pre-fill the fields. And let's walk through these fields just for you to know what to put where. So here, of course, enzyme name, the type, a short description, for example, cytochrome P450. And here comes the GenPep identifier and the UniProt ID. In this case, we don't have a MyBig identifier because this biosynthetic gene cluster was not described or added to the MyBig database yet. And also in terms of Wikidata ID, we don't have an ID, but that's fine. We can then add information about organic or inorganic cofactors. And since this is a cytochrome P450 enzyme, we can add iron and heme. And here we add the DOI of the reference. But this publication does not describe any auxiliary enzymes that would be required for this SHYB to function. So we leave this as is. Now about the reaction information. This publication here describes this cytochrome P450 and that it can take this pentapeptide, so methionine, arginine, histidine, glutamic acid, and tyrosine, and introduce this biaryl bond. In this case, it's an eta bond. When we read through the publication, we see that the authors also investigated some substrate specificity of the enzyme. So they did point mutations, and they exchanged the histidine in position 3 with tyrosine, with tryptophan, and with another histidine. Or I think they changed both here, I see. And they noticed that only the mutation of tyrosine was successful. So in this case, the substrate specificity or reaction specificity of this enzyme is both a tyrosine linkage, but also here a histidine-tyrosine linkage. And this information we can now draw, right? So we can do that with Catcher. And if you're interested in learning more about drawing reaction smiles and reaction smarts and smiles, we have a separate video for that. Just very briefly, what I did here, what I do here is we have under utilities, peptide smiles converters. We can specify peptide sequence. In this case, it's MRHEY. And we can create a smile string of that. We can copy paste this in Catcher. And this is how we draw the reaction. So we add atom indices. In this case, the reaction happens like that. So we would have the first reaction. Since the authors described two reactions, we would ideally draw both of them. If they were different, or how should I say, given that this was like a substitution of an amino acid, there's not a real good way to describe both of these substrate specificities in a single reaction, because yeah, we have different atoms here. But in theory, let's say that the authors would have also mutated this glutamic acid with all the possible amino acids, and they saw that this can be completely variable. We could just remove this part here, and therefore describe many reactions or many different possibilities as one reaction. So I already drew this. It's already pre-filled. And yeah, we add here a short description, a cross-reference to RIA or in C number if available. In this case, it's not described yet. And then we can specify the tailoring reaction term. The experimental evidence in this case was heterologous expression and in vitro assay. Specify a known reaction. In this case, it's the same as here in the reaction smarts, but just in SMICE format. Specify the intermediate, specify if it's an intermediate, yes or no. In this case, yes, because this product is then further modified by an unspecified peptidase, and then the end product is a tripeptide. And once this is done, so we also add a reference here. It's the same. And once this is done, we can take a look at the entry. So when we press on preview, then it gets checked, and there were no errors. So we are happy about that, and we can now inspect our reaction and our example. So this looks good. We specified everything. Case status is pending, of course. And since we created two reactions, we can also inspect that. And this is the difference, basically. So we are happy about that. If we weren't, we can go back by just clicking here on Edit Data. But we're good. Then we can specify an ORCID. Yeah, let's take my ORCID here. This is optional, so you can also do anonymous submissions, but then we cannot credit you, of course. Just be aware about the terms of use. So if you provide an ORCID, then this ORCID will also be publicly displayed. A brief changelog entry. So this is simply a new entry. And once we are happy with that and have ticked this box, we can press on Submit Entry for review. And that's it. So as you see, it's not very difficult. The main issue is reading the publication, right? Understanding it, finding the protein accession number, identifier, and then drawing the reaction in a sensible way. So thank you very much for being with me, and we are looking forward to your submissions.